Good afternoon. Today we are going to see two problems which are from exercise 2 and are on combined loading. Now this is third problem which was given in exercise number 2 of unit 5 and data given we will first write given data. So we have given capital D that is equal to 300 millimeters. Small d we have 200 millimeters. P is given 200 kilonewtons, and it is at outer edge of column. Calculate maximum and minimum stresses over the cross section. So now if we will draw the diagram of this hollow section, so we are being with hollow section in this way. So we have inside that is 200. So this is our column. Inside we have 200. Outside diameter is given 300. And P is given somewhere here. So we have here value of P. And therefore E if we will see, then we will get value of E that is equal to 150 millimeters. So E we have 150 millimeters. So now we will start with, we will calculate area, and we know we have for a hollow section pi by 4 into d square minus d square, and we have that is pi by 4 into 300 square minus 200 square, and from this we will get value of area 39.27 into 10 raised to 3 millimeter square. Then we will calculate value of I, which will be equal to pi by 64 in bracket d4 minus d4, which is equal to pi by 64. We have value of d is 300 to the power 4 minus 200 to the power 4, and that is equal to 319.07 into 10 raised to 6 millimeter to the power 4. And from this we can calculate z equal to 319.07 into 10 raised to 6 divided by d by 2. So 300 by 2, that is 150, and z we will get 2.13 into 10 raised to 6 millimeter cube. Now we have to find value of sigma d and value of sigma b. So sigma d we will get it as P by A, and that is equal to P we have 100 into 10 raised to 3, and A we have 39.27 into 10 raised to 3, and this will gives us value of sigma d that is equal to 2.54 MPa. And sigma b we will calculate sigma b equal to m by z. M we have 100 into 10 raised to 3 into 150, and divided by value of z is 2.13 into 10 raised to 6, and we will get sigma b that is equal to 7.04 MPa. And from this we will get sigma minimum equal to sigma d minus sigma b, and that is equal to 2.54 minus 7.04, and we have this value minus 4.5 MPa, that is sigma minimum is equal to 4.5 MPa, but this value we have tensile. And sigma max we have sigma D plus sigma B, and we have 2.54 plus 7.04, and we will have this value equal to 9.58 MPa, and that will be compression. And then we have second problem in this, that is fourth of exercise 2. So we have 8-meter high by 1.25 meter in section. So we can see this. We have 8 meter. This is height of this, and dimensions we have shown here also 2.5 meter by 1.5 meters. Mm, s- Wind pressure we have 1.4 kilonewton per meter square. Act on the face. So on this face, this is acting. So we have this face. On this face, this wind pressure is acting. Find the maximum and minimum stress intensities. The weight of the machinery is given 22.5 kilonewton per meter square. So first we will calculate area of cross section, which will be 1.5 into 2.5, and we will get this value, that is 3.75 meters square. Now I we have to find it. Now which I we have to find? So it will bend in this fashion, and as it is bent in this fashion, so we have to find about this axis, which is bisecting 1.5 meter. So we have B will be 2.5, D will be 1.5 cube by 12, and this value we will get it as 0.703 meter to the power 4. Then we will find total weight of machinery wall, that will gives us value of P, and therefore we have weight of machinery wall, weight of wall I can say, which will be equal to intensity of machinery into volume. Intensity of machinery is given 22.5, that is unit weight of machinery, into volume we have 1.5 into 2.5 into 8. 2.5 into 8. This is our value of P, and that value of P we will get. So P is equal to, we have this value 675 kilonewtons. Now we can have from this sigma D, that is direct load, equal to P by A. Now we have this P is 675, and area we have 3.75, and from this we will get value of sigma D as 180 kilonewton per meter square. Now this not relate with your other, that is eccentricity or anything. So moment will be developed by this 1.4 kilonewton per meter square. Now, what will be my value of moment? So value of moment we will get, that is M equal to wind pressure into area on which it acts. Wind pressure into area on which it acts, on which it acts into centroid of this, into centroid. Now we have wind pressure is given 1.4, on which area it is acting. So it is acting, you can see this 2.5 by 8. So we have into 2.5 by 8, and centroid we are going to be from bottom. So from bottom, centroid of this will be 4 meters. So we have into 4, and from which we will get value of M, and that is equal to 112 kilonewton meter. Now knowing value of M and value of I, we can find sigma B. So we have sigma B is equal to m by z. So m we have 112 divided by 0.703 into depth we know we have 1.5 divided by 2, and from this, so we have taken m by I into y, and that is equal to 119.5 kilonewton per meter square. And then we have sigma minimum is equal to sigma d minus sigma b. Sigma d we have 180, sigma b we have 119.5. So this will be 60.5 kilonewton per meter square. This is compression. And then sigma max we have sigma d plus sigma b, and then we will have this value equal to 180 plus 119.5, and that will gives us 299.5 kilonewton per meter square, and this is again compression. So this value we have at bottom, and that value we have at top. And then one question we have, that we have to find core of the section, and the diameter is given 200. So if we will go d by 8, so you are going to get, this will be actually third question from exercise 3. So d by 8 we have 200 by 8, so it will be 25 millimeters. And now if we will draw this 200 millimeter your circle, and then from this you have to draw another circle of 25 millimeters, and this will be my core of this section. And then we have d by 8, so that is 25 millimeter. So this total will go 50 millimeters, 25 on both sides. So this is your core of this section. This is third problem of exercise 3. Third problem, exercise 3, problem number 3. So these are the problems which are from your exercises of unit 5. So today we will stop here only. Thank you.